Okay, guys, let's complete the paper for today. In our last section, we looked at paper 4, February, March 2024. So today we conclude with the last question. Last session, we actually treated paper question 4. So today we move straight to the last question we have on this paper, and that is question 5. Question 5. So we make a start. Question 5 reads, butane and butanone are colorless gases at room temperature and pressure. Suggest why butanone diffuses quicker than butane. Okay, so you know from your elementary science, factors affecting diffusion. What are the factors affecting diffusion? Two main factors affect diffusion: temperature and mass. Okay, the higher the temperature, the faster the particle move. Then the mass, the bigger the mass, the higher the mass, the slower it moves. That's an inverse proportion. Okay. So here we are told that the temperature, both gases are the same temperature, room temperature. Okay, so if both gases are room temperature, if one is diffusing faster than the other, then it will be as a result of their mass. Okay, so let's look at them. Butane, you know butane is C4H10. You know the formula is an alkane, CnH2n plus 2. Whereas the other guy is C4H8. Okay, so you have CnH2n. That's the general formula for those guys. So obviously, even though the mass difference is small, I think it's just difference of 2, which is hydrogen atoms. Okay, 48 plus 4 times 12 of carbon, that's 48 plus 10. This guy, the mass of this guy is looking 58, while this guy is going to be 56. Okay, so your answer is simple. We can easily tell that the mass suggests why one is bigger than, has higher mass than the other. That's what you're writing. Okay, so you say butane has higher mass than butanone. Okay. Butane has higher mass than butanone. Okay, that's that. So you could say the other way around. Butanone has lower mass than butane. So that's the idea. Alright, that's simple enough. Okay, so we make progress now to the next question. Identify the products formed when butane undergoes complete combustion. Okay, you remember your definition of combustion? Combustion reaction is a situation when a substance, all the atoms in a substance, combine with oxygen to form the oxides of that compound, of that substance. So for butane is made of, is a hydrocarbon, so it's made of carbon and hydrogen. So if the atoms in butane combine with oxygen, they are going to form the oxides of that, oxides of the atoms that are present. So like we have mentioned, carbon is present in butane. I wrote the formula before now, sorry. So carbon is present in butane. When carbon completely combines with oxygen, we have carbon dioxide. Okay, carbon dioxide. And hydrogen in butane combines with oxygen. The oxide of hydrogen are reformed is water. Okay, water. Okay, so
we are writing phosphoric acid.
Okay, so that's that. That gives you your 1 mark, phosphoric acid.
So we make progress now. I think that's satisfied that question. Separate the bonding. Okay, so you have O here, then you have hydrogen attached this way. Okay, so this is the display formula. All the bonds are oxygen connects to hydrogen, oxygen connects to carbon, single bond. Okay, now the situation whereby we have it at butane 2 Okay, so you have OH. This way you have H. Okay, then you have this. You have H. You have H. Alright, I guess you don't have issues with the display formula. In the display formula, you are showing how all the atoms connect themselves with either single bond, double bond, triple bond, as the case may be. Okay, so we are making progress. Now, both 1 undergoes polymerization. All double bond will undergo polymerization, and they will always undergo addition polymerization. There are 2 types of polymerization. We have condensation polymerization and addition polymerization. In a condensation polymerization, you have 2 molecules joined together to form 1 large molecule and a loss of small molecule. Okay, when you do when ethanol or an alcohol reacts with carboxylic acid to form an ester, that's an example of a condensation reaction. Okay, there will always be a loss of water. So water molecule is lost and a big molecule of ester is formed. That's a condensation reaction and condensation polymerization if you go polymerizing. Okay, so here we are looking at both 1 undergoing polymerization. You have many monomers joined together to form just 1 product, and that's why we call it addition polymerization. No other product will be formed, only 1 product, and so we call it addition polymerization. You know the definition for addition reaction, where 1 product is formed. Okay, addition polymerization. Okay, addition polymerization. That's it. So you have addition polymerization. Now we are making progress. Okay, it seems to be the last question. Now draw part of the polymer molecule to show 3 repeat units. Now please note that in our last diagram I drew butane in this fraction. Okay, I think this is how it was drawn in this fraction. Okay, so if you are going to do anything polymerization, okay, what you are going to do is to this end. Oh, sorry, I've just killed chemistry. Okay, that is too much of bond for that carbon atom. Okay, so every carbon atom must always have 4 bonds around it, so that was too much. Okay, so when you are doing polymerization reaction, addition polymerization to be specific, the reaction is always within the double bond. The double bond is usually the center of reaction. So when you are asked to draw the repeat unit, this other end, you flip it over and come this way, because your focus is within this carbon to carbon double bond. Your focus will always be within the carbon to carbon double bond. So we are going to redraw this guy now. We are going to redraw these guys such that every other carbon other carbon atoms are drawn like a side chain. So you don't necessarily need to show all the bond. So those ones that I have removed are C2H5. Okay, C2H5. To do it properly, you want to to do it properly, you want to show that the bond is connected to carbon, not hydrogen. Okay, C2H5. You put it this way. So our attention is this. So when this happens, this bond, when the polymerization happens, one of these bonds will be removed to continue the joining together. You know, the small molecule, this is the small molecule joining to other molecule. So joining to the same molecule, the same small amount of molecule. So this is the monomer. This is how we draw the monomer, because our attention is on this carbon to carbon double bond. That's where our focus is. So when the reaction takes place, one of the double bond will be broken and be used to connect to others. Okay, so we need to draw the set 3 more units. So we need to, that one of the double bond is used to connect to another of this. So you have C2H5 connecting to this. Okay, see this connection. Okay, then you draw another one, the double bond here also broken to connect to other one. So this is a continuation bond. We come here again to see a situation where to make it the 3 units. Okay, to make the 3 units, so you have C2H5 and you have H here. You draw a continuation bond. So for every repeat unit, you will need a continuation bond. This guy, we are referring to it as a continuation bond. If they ask you to draw repeat unit, all repeat unit must always have a continuation bond. Okay, now you could see that to show that we have just 3 monomers. 1, 2, 3, 4, 5, 6. To show that we have 3 monomers, the carbon in the chain of the polymer are just 6 carbon. I told you when you do addition polymerization, the focus is at the double bond. The focus is at the double bond. So however the molecule is naturally, you want to flip it to focus at the carbon-carbon double bond. Okay? Your attention should be drawn to the carbon-carbon double bond. So in the long chain of the polymer, you are only having carbon-carbon double bond. So if you are asked to draw 3 repeat units, you are going to have 6 carbon chain and a continuation bond, because your focus is carbon-carbon double bond. 2 carbons at the center, 2 carbon at the center. Draw 2 repeat units for any addition polymerization. You are going to have 4 carbon on the straight chain, because your focus is on the carbon-carbon double bond. Every other attachment, flip every other attachment such that you will always have carbon-carbon double bond on the straight chain. Is that okay? So if you are asked to draw 5 repeat units, you know that on your carbon straight chain, you are going to have 10 different carbon atoms connected to each other with a continuation bond. That way, you will be able to remember how to draw the repeat unit for every addition polymerization. So please don't get it twisted. Always remember to include repeat units. Always remember to include continuation bond when you are asked to draw repeat units. And when you are thinking of addition polymerization, concentrate on the position of the double bond and flip every other attachment. Flip it such that you will always think of the carbon-carbon double bond.